Good morning, sir. This is Janardhan, Associate Professor, Department of Computer Science and Engineering in G. Pullaya College of Engineering and Technology. Today, I would like to explain formal languages and automata theory. That is a non-deterministic finite automata. It can consist of that is a 6 tuples. What is by non-deterministic finite automata? For each and every input symbol, there may be more number of transitions out of each state. It is nothing but non-deterministic finite automata or NFA. NFA finite automata is of course non-deterministic, implying that the mission can exist in more than one state at the same time. Transition could be non-deterministic. For example, Q1 on 1, either Q1 or Qk. That is nothing but you cannot determine. That's why you can call as a non-deterministic finite automata. In non-deterministic finite automata, it can consist of that is a 5 tuples. And what are the 5 tuples is here there is a Q, sigma, Q naught, F, and then delta. Q is the set of final states, and then sigma is the input symbols, and then Q naught is a start state, F is a set of accepting state, and delta is a transition function, which is a mapping between Q to sigma is tends to subset of Q, that is a power set of Q. NFA is also defined by 5 tuple, that is Q, sigma, Q naught, F, and delta. How to use an NFA? That is for each and every input symbol, more number of transitions out of each state is nothing but that is the non-deterministic finite automata. Here, determine all possible next states from all current states given the current input symbol in W and the transition function. If after all symbols in W are conjugated and if at least one of the current states is a final state, then accept W. Otherwise, reject. And NFA for strings containing 0, 1. For example, observe here Q is the number of states, here Q0, Q1, Q2 is the number of states, and sigma is the input symbol 0, 1. And what is the delta is a transition function which can map Q into sigma is tends to 2 power Q. But the example here 0 and 1. Q0 on 0 is the Q1, and then Q1 on 1 is the Q2. That is a Q0 on 0, either Q0 or Q1. There may be a path from initial state to final state. The string is accepted by non-deterministic finite. That is the non-deterministic finite automata. And then we can go for the difference between DFA and then NDFA. In DFA, for each and every input symbol, there must be exactly one transition out of each state. It is nothing but DFA. In NFA, for each and every input symbol, there may be more number of transitions out of each state. It is nothing but that is the NFA. And what is the main difference in DFA and NDFA? One is the delta. Delta in NFA, Q into sigma is tends to 2 power Q, that is the power set. And whereas in the DFA, Q into sigma is tends to Q. And then second difference, for each state transition on the all possible symbols, and then here NFA, not all symbols transitions need to be defined explicitly. And then third difference, accept input if the last state visited is in F, or otherwise accept input if one of the last states in F. That is the difference between DFA and then non-deterministic finite automata. And then next we can go for the NFA and DFA, how to convert non-deterministic finite automata to deterministic finite automata. For example, observe here a diagram Q0, Q1, Q2 the states, and then Q0 on 0, either Q0 or Q1. The given diagram is a non-deterministic finite automata, and then how it can convert non-deterministic to deterministic finite automata. Observe the first one is the Q0 on 0, the Q0, Q1, and then Q0 on 1, Q0. And we can take the new state. New state is the Q0 on Q1. And what is the Q0 on Q1 on 0? That is the Q0 Q1. On 1 is the Q2, Q0 Q2. And then next we can take Q0 Q2. Q0 Q2 on 0 is the Q0 Q1 Q2. Like that only. That is a conversion of non-deterministic finite automata to deterministic finite automata. And then repeating the example, that is a lazy creation. Here also can conversion of non-deterministic finite automata to finite automata. And then main applications of automata. Here, without participation of man, we can use compiler design and then pattern recognition and then extension of this data. For example, lexical, you can use the lexical analyzer and then what is the lexical analyzer? For example, compiler. Compiler is a translator which can convert high-level programming language to low-level programming language through some phase of compilation. Here, first one is the lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generation, and code optimization. Application first one is the lexical analyzer. Lexical analyzer scans the read input source program. It can divide into number of tokens. These tokens can be treated as a groups, or token is simply we can say that group of characters. That is the invented indexing. For each unique word in the database, store all locations that contain it using an NFA to DFA. Find pattern recognition and then patrika tree and then suffix tree.